is going to be very smooth. Okay. When we solve inequalities, we can solve them almost the same as when we solve equations. There's one little difference that we're going to talk about tomorrow. Okay? But what you see today will feel very familiar compared to what we did in our equations chapter. Okay? So, if you have an equation or an inequality, A is greater than B, then we can add the same number to both sides. Same thing if it's less than, we can add the same number to both sides. Okay? So just like an equation, we can add the same number to both sides of an inequality, and we still have a true statement. Okay? For example, if we have x, well, here, let's see, example. X minus 7 is greater than 10. Sorry, Miles. Okay, if I want to get x by itself, it is completely legal to add 7 to both sides of the inequality. Okay, so we're still like balancing across our symbol, but instead of an equal sign, it's an inequality sign. Okay, so we can add 7 to both sides, and now we have x is greater than 17.
Is there going to be times where we have to switch the sign?
We'll talk about that tomorrow. Okay. Now, if I ask you to graph this bad boy, then at 17, would we have an open or a closed circle? Open. And Aubrey, I heard your voice loud and clear. Why is it open? Okay, since we don't have that line, since it's not equal to, we have an open circle. And are we going to go to the right or the left?
Right.
We need to go to the right because we want numbers greater than 17. Okay. Example number 2. Okay. Now, if I want x to be by itself, then I need to undo that minus 3. To undo subtraction, we know we can use addition. So if I want to undo the 3, I can add 3 to both sides of our inequality. So instead of the equal sign, it's the inequality. That's fine. We're still balancing by adding the same number to both sides. Okay. So what do we get? We get 7 over here. Okay. Now, I do not mind if you leave your answer like this, but I think a lot of us are more comfortable when the x is on the left side. So you can leave your answer like this, or you can rewrite it where you can flip-flop where x and 7 are, but please make sure the sign is opening to the number it's supposed to. So do you see how the alligator is opening to the x? We need to make sure it still does that when we rewrite it, okay? So we have x is greater than or equal to 7. So when we graph it, we will have a what kind of circle at 7? A closed circle, and since it's greater, we'll go to the right. Okay. How does that feel? It feels like maybe you could have done that without me?
Maybe.
Maybe? But it's better with me? Okay, thank you, Julie. Thank you. That was a very immediate yes. Okay, so let's go to the next page. Okay, so the same thing. We can subtract the same number from both sides of the inequality and produce still a legitimate statement. Okay? It is okay to subtract the same number from both sides of the inequality, and we still have a true inequality. So, for example, if we have k plus 3 is less than or equal to 4, okay? If I want the variable by itself, if I want k by itself, I need to get rid of that 3. Well, since 3 is being added to k, I can undo it by subtracting, okay? So I know I want to subtract 3. And if I subtract it to one side of the inequality, I would have to subtract it from the other side as well. You probably don't need that line, but I'm trying to just emphasize that we have two sides and we need to balance across the two sides. So we end up with k is less than or equal to 1?
Yeah.
Okay. So what do we have at 1? A closed circle. Okay. And since it is less than or equal to 1, we need to go smaller numbers. Okay. All right. I would like you and your elbow partner to do number 1 and 2 and agree on the answers and the graph. I'll give you 2 minutes.
Supposed to subtract. It'd be an open circle. That's already subtracted. -3 plus 3 is doing all of them or just 1?
1 and 2.
The next one, wait.
Do we have to write out the whole number line?
No, I'm not doing that.
No, just the number. Just the one number is fine right now.
Wait, 0 in the middle and then the number and then
You can't do that for everything.
Yeah, so what you can do is, like you can say, all right, -2, -1, 0, and then whatever you need to do.
I just do the 0 in the middle, and then if it's like 5, then I do 5, 10.
Okay, okay, as long as you label it, it's pretty okay.
I'm sure it's fun at the end of the day, but not when you have to come and use
What?
I had PE before this every single day.
Oh, and you just don't like that?
I hate having it.
I don't have that. Oh, I just realized.
Yet.
I'm not gonna have PE.
All right, Camden, what did you get for number 1?
Like for the graph?
Or for your inequality, like x is
X is less than -1.
less than -1. So it seems like Camden added 3 to both sides. He got x is less than -1. So at -1, we have an open circle and we've shaded to the left.
Yeah.
Does that look good? Okay. Now, what about for number 2? Rachel, what do you have for number 2? So 0 is greater than h. We can add 3 to both sides to get 0 is greater than h, which is the same thing as h is less than 0. So at 0, we have an open circle, and please make sure you're going to the left because the numbers are getting smaller than 0. Is that okay?
Yeah.
Ava, what's your question?
Nothing.
Okay. Now, if you're trying to use the arrow trick to figure out which way to shade, then your variable has to be on the left. If the variable is on the left, yes, this is telling you which direction to go, but your variable has to be on the left. Okay. Now, if you look at the top of the next page, like number 4 and number 5, you'll notice that there's a few extra things compared to the 2 before. So we're going to look at number 4. Okay? Interesting. What do you think we need to do first? We need to combine like terms. Just like we did with equations, you better combine like terms before you start moving things over. Okay? So I'm going to draw my line just for emphasis, and I'll draw it yellow so it's not like super bright. Okay? Notice how we have 2 things alike on the same side. So we can take 6 minus 9 to get negative 3 plus u is less than negative 2. Now, if we want to get u by itself, we would need to do what with this 3? Since it's a minus 3, we need to undo it by adding 3 to both sides. So we end up with u is less than 1. I like to squiggle just so you can tell that it's there. Some of you are using pencil, and if you're using pencil on that black line and you just do this, it's going to be really hard for me to see. Yes?
Can you write above the number line?
Yeah, that's what I do.
Yeah. So, you're like this.
No, you like put the circle above the tallies and then draw a line.
Like that.
Kind of this.
Yeah.
Yes, that is perfectly fine. Yep. Okay. All right, so in number 5, are we ready to start moving across the sign? No, because we have like terms. Now I'll do this just for emphasis. 4C and 3C are on the same side, so we do that operation. We have 12 is less than or equal to 4C minus 3C is 1C. Okay. Eliza, what do we need to do to get C by itself? We need a minus 10. So we can minus 10 from both sides to get 2 is less than or equal to C. I like rewriting it to be the variable on the left side. If I do that, if I put C and 2 and I flip-flop their places, I need to make sure that my sign is still opening to the same number, or in this case, variable. Okay, so at 2, we have a closed circle, and we're going which way? Going to the right. Okay. All right, you and your elbow partner work on number 6. See if we can get an answer there.
You need to get X and Y. Because minus 2 and that's 2. Yeah. That's not what you said. 15. I got negative. Oh.
I got -2. I got P is greater than negative.
Yeah.
Well, no, but that would be, if you combine it, that would be negative 7p plus 8p. So that would be
So negative 7 plus 8p is 1p. It's okay. It's okay. We can make mistakes and then fix them. $15. What are we dividing? 15. I think it's a 1p, not a 15p.
yeah, it's a negative.
Did you? Did you?
Okay. All right. Eva, what did you end up with? P is? Divide.
No, you don't.
I don't think there's any division in this one. Okay, I think we need to address this problem. Eva, you are not the only one to have made that mistake, so do not panic. Okay? On the left side, we have negative 7p plus 8p, which is what?
Negative P.
Just 1p. So on the left side, you should have 15 plus 1p. And over here on the right side, 15 minus 2 is 13. Tinley, what do we do next? Now, hey, stay with me, stay with me. Now we can minus 15, so P is greater than negative 2. That's terrible. Are we okay with that? Okay. Please make sure that when you're combining like terms, because this was a common mistake, so don't panic. We all know we need to add, but make sure you're looking at this sign in front because that is connected to the 7p. It's minus 7p plus 8p, okay? Make sure you're looking at that. Okay, let's take a real life situation here. You have $15 to spend on groceries. You have $12.25 worth of groceries in your cart. Write an inequality that represents how much more money you can spend on groceries. M is what? How much more you can spend. And you have a total of 15. I don't know who wrote this and how long ago it was, but it's not getting you a whole lot.
Just use a dollar sign instead.
Okay, what do I do with the M and the 12.25 and the 15? If I'm going to use all three of those things.
Combine that term.
What'd you say? Okay, Okay. We have 12.25 in our cart. Plus, maybe we're going to buy some more. How does that going to compare to 15?
Less than or greater than or equal to.
Less than or equal to. Because we can't spend more than 15. So what we buy has to be under 15 or right at 15. which means we have to spend less than or right at $275. Right? Okay. Yes.
Aren't you technically able to spend $15 if you haven't spent any yet?
Well, what they're saying is like, this is in my shopping cart.
What they're saying.
Like, what can we put in our shopping cart and still be under budget? Okay, now I'm going to give you a little treat. Go ahead and turn the page maybe more than once to this page. So maybe more than once. Yep, right there. Okay, so page 40. I'm going to let you get ahead of the game here. Somebody asked about dividing by a number, and we didn't get to do that, but I'm going to tell you we're going to get to do that a little bit today. Now, as long as the number is positive, we can multiply or divide each side of our inequality by a positive number and it not affect our inequality. Okay? So, down here in the notes, I want you to write down these examples. Okay? If we have 5x is greater than or equal to 20, if 5x is greater than or equal to 20, well, then in order to get x by itself, we would have to divide by that positive 5, and it would be totally fine to write that x is greater than or equal to 4. Apparently we're going a parallelogram today. I tried to make a circle and it made a parallelogram. I don't know why. Just gonna go with it. Okay. We could also fine. X over 10 is less than negative 2. Okay. Since we are dividing by 10, to undo it, we would need to multiply by 10 to each side. So we get x is less than negative 20. Is the number we are multiplying by positive? Yeah. This guy is positive. That's what matters. Okay? That is a question for tomorrow, my dear. Tomorrow we will talk about if that number is negative. Okay? One more problem, just because I'm worried about you remembering. 2/3 x is greater than or equal to 4. I just want to make sure we remember how to do this. Technically, 2/3 is being multiplied to x, so we want to divide by 2/3, but dividing by 2/3 is the same as multiplying by 3/2. So that we get x is greater than or equal to 4 times 3 divided by 2. Okay. Which is 6. Okay. You will notice that in Google Classroom, on your gold sheet, on the board, the 3 different places you'll find your homework, there's going to be 2 different pages attached. You're going to have 2.2 and sum of 2.3. So from page 65, you're going to do 7 through 25 odd. And from page 71, you're going to do 3 through 10 all. These are just simple inequalities. Okay.